Hey everyone, welcome back. Again, we are starting with the same building blocks from before, but this time we are going to talk about everything pertaining to inheritance in this lesson. So without further ado, let's go ahead and get started. So again, if you want to get the lay of the land, we have the ownable.sol file with the same starting point. So if you want to stop the video really quick and get that down, please feel free to do so. I'm going to go ahead and create the address really quick, and we'll say public owner constructor, which will be public owner is equal to msg.sender, and we will grab a modifier. In this case, we're only going to accept the owner. So only owner. And this will require that the msg.sender be equal to the owner that we specified. When we initially created this contract. So when the contract is sent, this will be the owner, or that's who it's supposed to be, at least. So at least we'll say must be the owner. Oops. There we go. All right. And we're also going to end execution here. So we'll give that a underscore and semicolon. And that is it for this contract. So that is the ownable contract. We're then going to create a secret vault contract as well. So contract, we'll call it secret vault, which will have a string called secret inside of it. That will have a constructor as well. And we will pass a string of memory, which will be secret public secret, set that equal to underscore secret. Cool. And this will have one function inside of it, which will just be get secret, which will have public view returns string, place that inside of the computer's memory, and return, I can spell, return secret. Awesome. And our last contract is going to grab hold or inherit of ownable. Yes, ownable, sorry. So contract, my contract, my contract is ownable. And as I'm looking at this, I might want to change the name of our file. So it's my contract instead of ownable, because my contract is the actual thing. So we'll say address secret vault, or vault. Yeah, there we go. We'll then give this a constructor, which will be string memory secret public. We have secret vault, and that will be underscore secret vault. And let me make sure this is under. Yeah, there we go. There we go. Making sure that we got everything in there. We'll create a new secret vault, which will pass in secret. So we're basically instantiating a new value for, or a new space for secret vault to live when we create a new part for that. or new value for that inside of the computer's memory. Then we'll do secret here again. So secret vault is going to be equal to address secret vault. And then super is going to bring all the constructor stuff and anything that would be otherwise created on initialization down with it as well, so that we don't have to copy and paste that every single time. And then we'll say function get secret, which will be public view only accessible from the owner. So only owner. And it will returns string memory. Okay. We'll then grab the secret vault, set that equal to, or we're going to create a secret vault, in this case, secret vault. Come on. There we go. Equal to secret vault, which is going to pass in the address secret vault. So this guy right here. Secret vault. And it's going to return secret vault dot get secret. Okay. So we did a lot. We did a lot specifically around this guy right here. So my contract is going to be ownable, or an extension of ownable. So we're going to have the ability to gain access to the only owner modifier. That's what we have available here. So if you take a look at what we were trying to gain access to when we did everything, we're saying, hey, we want all of the stuff that's inside of ownable to be given to us by the super. So we're basically backtracking. So sorry, the way this would look inside of the computer, we're basically saying my contract is going to backtrack and look inside of ownable and see what it has inside of it. And whatever is inside of that is going to then get passed inside of my contract as well. So that's why we can do only owner from here, because we passed in ownable and all of the information from the super inside of ownable specifically. So from here, everything else is being created on the fly. So we're saying secret vault, give me, or we're saying what we want this to look like, which in this case is going to be a secret vault object. We're going to call this, or internally call it underscore secret vault. And when we actually pass information into underscore secret vault, we're going to create a new instantiated value, or create a new contract in this case of this guy. So we're going to basically do this guy and place it all the way, all of that inside of here. So all that data or information is going to be placed inside of here. And then we're also going to take that and give it a value, so an address in this case. So that is going to be this guy right here. After all that's done, then we can look inside of get secret and actually get access to, as long as we go through the correct steps in this case. So secret vault, secret vault dot get secret, which in this case means go here and then go here. Give me access to this return value here. As long as we do that, we can get access to whatever secret we have stored inside of this returned value. So let's go ahead and excuse me, compile this down. I'll leave the name as ownable for now. And let's, I missed a comma somewhere, it looks like. Line 38. Got the comma, but got memory. String. Get secret hole. There we go. Fat Finger McGee strikes again. Sorry about that, folks. There we go. Return string memory. There we go. Now we should be good. Awesome. We do have some warnings, but it looks like it's all just visibility for the constructor stuff. So we like public here, and public here. It's basically what it's telling us. So we can clean that up if we wanted to. We don't necessarily need those. So we'll say public, you can go, and you can go. But again, we could leave them. So remember, technically, we could leave these here with no problem. It's just going to give us warnings every time. But if we don't want to, if we don't really care about the warnings, you can leave them there. But that's taking the public modifier off of the constructor. So just so everyone's clear on what we're removing, that's the public constructor or public modifier off of the constructor inside of each of our contracts, as it were. But I'm going to leave them for now. But again, if you want to clear these warnings up, that's what it's basically pointing out right now. We'll go ahead and deploy this guy. I will make sure that all the other contracts are gone so as not to confuse myself. And we will then go ahead and deploy Ownable. I didn't give it a secret, so it's completely blank. So let me actually do that again. I'm going to clear that. And I'll just give it a random gobbledygook of a string, and then we will deploy. Let's see. Yeah, we'll just go ahead and deploy there. I'll go ahead and ask for, so remember that the contract that we're actually accessing right now is this one right here. So get secret is the value that we're looking for. But notice that we also have owner here as well, which is coming from this guy up here. And we have that for free because it is a state variable and it was given to us by the ownable contract. So we inherited that value. So if we look inside, we could get the get secret. So whatever that was that we put inside of there. And then the owner. So that should be, if I'm not mistaken, that should be this guy right here. So if we say owner, yep, same exact thing. So this is how inheritance works inside of Solidity. It's very, very similar to other object-oriented programming languages, but the only slight difference is that we have addresses and things of that nature that we can keep track of. But in essence, it is very similar to a C++ or a Java object in object-oriented programming in those types of languages. So if you want to do a more deeper dive on the history of object-oriented programming, you can also go inside of those languages because Solidity is a C-style language, so it's very similar to C, C++, and those types of things. So with that said, now we can transition into the basics of JavaScript and understand how the ecosystem of JavaScript works. From there, we will move on into creating contracts and putting all this stuff together. So I'll see you in the JavaScript section.